So today I can complete mini proofs by drawing conclusions using my definitions. A very important lesson. It kind of ties together what we did the past couple days, and we're going to need this moving forward. We're going to do this today. We're going to practice it tomorrow, and then we're going to quiz it at the end of class tomorrow. And it's all based on your 6 definitions, so you might want to, when you have these written down in the front of your packet, you definitely want to have them nearby to refer to as you're going through. And let's kind of roll from here. So, I'm going to show you a new structure today. In the past, we just wrote the conclusion and wrote the reason, but now we're going to introduce what we call a 2-column proof. And here's what we're going to do. I'm going to write statements, reasons. The first statement is going to always be the given. The given in this example is GE is an altitude. The first reason is given. So out of the 2 steps to this, the first one is always the given and the reason is given. Now, I like to always do the second reason before the second statement. I'm going to be using my altitude definition. So I can refer to my list if I don't have it memorized yet. And an altitude creates 2 congruent right angles. So that's going to be my second reason. An altitude creates 2 congruent right angles. So what you need to do is you need to find the right angles. Well, if GE is an altitude, the right angles are where the altitude hits the base. My right angles are at E. There they are. Now I just need to name them. When I name angles, the vertex must go in the middle, so E must go in the middle for each of them. So I'm going to say that angle GED is congruent to angle FEG. And again, the reason is an altitude creates 2 congruent right angles. That's how we do a mini proof. Statements and reasons. The first statement is always the given. Reason is always given. Then I'm drawing my conclusion. My second reason is one of the definitions that I'm using. And the statement is whatever the conclusion is. If it forms congruent right angles, then you're telling me what the congruent right angles are. Number 2, ON bisects angle TNM. Statements. Reasons. The first statement is always the given. In this case, ON bisects angle TNM. And the first reason is always given. Now I see bisect. I have to determine if it's a line bisector or an angle bisector. The question is, what's being bisected? If ON punches angle TNM, what's getting punched? Well, angle TNM. Angle TNM is an angle, therefore it's an angle bisector. If an angle is being bisected, it's an angle bisector. If a line is being bisected, it's a line bisector. An angle bisector creates 2 congruent angles. So I need to find my 2 congruent angles. For angle bisector, the congruent angles are where the initial angle is being cut. So what's the vertex of angle TNM? N. That's angle TNM. Those are my 2 congruent angles. And if you need to look back in your definitions packet at more examples of angle bisector, go for it. That's why it's there. So N must go in the middle for both because N is the vertex of both of those angles. Angle TNO is congruent to angle MNO. and that is your mini proof. The goal for a mini proof is to tell me that two things are congruent. Because for what we're going to be doing with this, we're going to always want to prove that pairs of sides or angles are congruent. Number 3, midpoint. I want everyone on their own to try and put the first statement and first reason in. So everyone right now on your own, I want you to try and fill in the first statement and the first reason. And again, if you want to look back, your first statement is always the given, and the first reason is always given. Okay, the first statement should be A is the midpoint of dV, and the reason given. Now, I like to do my second reason before my second statement because my reason will help me with my statement. Midpoint, I go back to my list of definitions, which you are going to have memorized at a certain point. Normally, I would quiz you on your definitions, but I don't know how I'm going to virtually quiz you on your definitions because you're just going to like copy and paste them. And so, a midpoint creates two congruent segments. So what you have to do is tell me what the two congruent segments are. If A is the midpoint of dV, well, dA and AV. And again, if you need to, look back at the definitions packet where you have a whole page for each definition and use it to refer to. It's also very important that you are marking your picture. For what we're going to be doing, you're going to need to mark your picture. I mean, I can go over one of each definition, but I feel like it's all pretty much the same. It's the same procedure. What I do want to do is go over one from parallel, because parallel is kind of tricky, and I know I gave that to you to do yesterday. So let's just skip ahead to a parallel one. Number 7. And then after that, I'm going to give you time to practice everything on your own. So let's just get through this one. Statements, reasons. SE is parallel to RB, given. Now with parallel, I want to extend my parallel lines and then find and extend my transversal. So I have 2 transversals in this example. Let's deal with one at a time. I'm going to put my 8 dots where the parallel lines hit that transversal. Out of each of those clusters of 4, I need to find the angle that's inside of a triangle. This one is inside the triangle, and this one's inside the triangle. So angle SEA is congruent to angle BRA. Now before I put the reason in, again, parallel is a little bit different. Let's do the other transversal. Dot, 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 dot. Which of these is an angle of a triangle? This one and this one. So we have ESA and we have RSA, RBA. Now the reason for parallel, it always starts with, and this is a long one, parallel lines cut by a transversal create congruent. Now there's three options. There's alternate interior, alternate exterior, and corresponding. To determine which one it is, I'm going to color inside the parallel lines. If they're both inside, it's alternate interior. If they're both outside, it's alternate exterior. If it's 1 and 1, it's corresponding. Let's look at the blue angles. This blue angle is inside the green. This blue angle is inside the green. Since they're both inside, they're going to be alternate interior angles. If they were both outside, they would be alternate exterior angles. If it was 1 and 1, they would be corresponding angles. And again, we did yesterday's lesson on that. So, we didn't do all 7 of the definitions, but we did enough for you to basically get the gist of it. Your first statement is always the given. Your first reason is always given. From there, you're drawing the conclusion just like you did over the past 2 days. So,